Naïve Bayes Classifier for Business Analytics. Introduction. In the realm of business analytics, the Naïve Bayes (NB) classifier is a powerful tool that leverages probabilistic principles to solve classification problems. By applying Bayes' theorem and making the naive assumption of feature independence, NB allows us to predict outcomes based on available data. In this crash course, we will explore the Bayes and NB formulas, discuss why the classifier is considered naive, and delve into the pros and cons of using NB in business analytics. We will also demonstrate how NB can be applied to predict customer churn using the Telco Customer Churn dataset. Bayes' theorem. At the heart of the Naïve Bayes classifier lies Bayes' theorem, which provides a way to calculate the probability of an event based on prior knowledge. The theorem can be stated as follows.
PA vertical bar B equals PB vertical bar A PA, PB.
Where PA vertical bar B is the probability of event A occurring given that event B has occurred. PB vertical bar A is the probability of event B occurring given that event A has occurred. PA is the probability of event A occurring. PB is the probability of event B occurring. Naïve Bayes formula. The Naïve Bayes classifier extends Bayes' theorem to make predictions based on observed features. Given a dataset with features x_1, x_2, x_n, and a target variable y, the NB formula can be expressed as
PY vertical bar x_1, x_2, x_n, equals px_1 vertical bar y px_2 vertical bar y, px_n vertical bar y py, px_1, x_2, x_n. The naive assumption. The Naïve Bayes classifier makes the naive assumption that all features are independent of each other, given the class label. Although this assumption rarely holds in real-world scenarios, the classifier's simplicity and computational efficiency make it widely applicable. The assumption allows for a straightforward estimation of conditional probabilities, even with limited data. Pros. Plus simplicity, NB is easy to understand and implement, making it accessible to beginners. Plus efficiency, the classifier is computationally efficient, making it suitable for large datasets and real-time applications. Plus scalability, NB can handle high-dimensional datasets with numerous features without significantly affecting performance. Plus interpretability, the probabilities produced by NB can provide valuable insights into the relationships between features and the target variable. Plus robustness to irrelevant features, NB tends to perform well even when irrelevant features are present in the dataset. Cons. Feature independence assumption. The naive assumption may not hold in complex real-world scenarios, leading to suboptimal predictions. Limited expressiveness. NB may struggle to capture intricate relationships between features, resulting in reduced accuracy compared to more sophisticated algorithms. Sensitivity to imbalanced data. NB assumes that features are equally important, making it sensitive to imbalanced datasets where rare classes have limited representation. Predicting customer churn with Naïve Bayes classifier. To illustrate the application of the Naïve Bayes classifier in a real-world business scenario, we will use the Telco Customer Churn dataset. This dataset contains information about telecom customers, including demographics, services used, and churn status. We can employ the Naïve Bayes classifier to predict whether a customer is likely to churn or not based on their features. By calculating the probabilities of churn/non-churn for each feature, we can use the Naïve Bayes formula to estimate the probability of churn given the customer's features. Let's consider an example where we want to predict customer churn based on the features available in the Telco Customer Churn dataset. The dataset can be loaded from the file w8_fnusec_telco customer churn.csv using appropriate data manipulation and preprocessing techniques. Once the dataset is loaded, we can start by performing exploratory data analysis to understand the characteristics of the data and identify relevant features for our churn prediction task. Some potential features that could be useful for predicting churn include customer demographics, for example, age, gender, type of services subscribed, for example, internet, phone, contract details, for example, contract duration, payment method, and customer behavior, for example, monthly charges, total charges. Next, we can split the dataset into a training set and a test set.
The training set will be used to estimate the probabilities required for the Naïve Bayes classifier, while the test set will be used to evaluate the performance of the classifier. To apply the Naïve Bayes classifier, we need to calculate the following probabilities. Prior probabilities. P churn, the probability of a randomly selected customer churning. P non-churn, the probability of a randomly selected customer not churning. Conditional probabilities. P feature vertical bar churn, the probability of a specific feature value given churn. P feature vertical bar non-churn, the probability of a specific feature value given non-churn. We can estimate these probabilities by calculating the frequency of each feature value within the churn and non-churn groups. Smoothing techniques like Laplace smoothing can be applied to handle cases where a feature value does not appear in one of the groups. Once we have estimated these probabilities, we can use the Naïve Bayes formula to predict the probability of churn for each customer in the test set. By comparing this probability to a predefined threshold, we can classify customers as either likely to churn or likely to stay. Evaluation of the classifier's performance can be done using various metrics such as accuracy, precision, recall, and F1 score. These metrics provide insights into the classifier's ability to correctly classify churn and non-churn instances. Interesting stories or examples. Telecom company. A telecom company wants to reduce customer churn by identifying customers who are likely to switch to a competitor. By applying the Naïve Bayes classifier on their customer data, they can proactively reach out to high-risk customers with targeted retention offers, leading to reduced churn rates and increased customer loyalty. E-commerce business. An e-commerce business wants to identify potential fraudulent transactions to minimize financial losses. By utilizing the Naïve Bayes classifier on transactional data, they can identify patterns and features associated with fraudulent behavior, allowing them to block or investigate suspicious transactions in real time. Email spam filtering. Email service providers use the Naïve Bayes classifier to classify incoming emails as spam or legitimate. By analyzing various features of emails, for example, sender, subject, content, the classifier assigns a probability of spam to each incoming email, enabling effective filtering and reducing the user's exposure to unsolicited messages. Here are 12 popular applications of Naïve Bayes in business analytics, along with a brief description of each. 1. Spam email filtering. 2. Sentiment analysis. 3. Customer churn prediction. 4. Document classification. 5. Medical diagnosis. 6. Fraud detection. 7. Customer segmentation. 8. Credit scoring. 9. Disease risk prediction. 10. Image classification. 11. Market basket analysis. 12. Text categorization. In this crash course on the Naïve Bayes, NB, classifier for business analytics, we explored the foundations of the NB algorithm, including Bayes' theorem and the NB formula. We discussed the naive assumption that NB makes regarding feature independence and examined the pros and cons of using NB in business analytics. To illustrate its real-world application, we utilized the Telco Customer Churn dataset to predict customer churn using NB. Overall, both Naïve Bayes and support vector machines offer valuable techniques for analyzing data and making informed decisions in the realm of business analytics. By leveraging the power of these algorithms, businesses can gain insights, optimize processes, and drive growth in today's data-driven world. Poem. In the realm of data, where insights reside, a classifier emerges with knowledge as its guide. Naïve Bayes, the hero of business analytics. With its algorithms, it works wonders, performing miracles. Oh, Naïve Bayes, a shining star so bright. In the world of classification, you bring us light. With assumptions so simple, yet incredibly clever. You navigate through data, forecasting forever. In the land of spam, where emails roam, Naïve Bayes stands tall, protecting our home. Filtering messages, distinguishing the fake. Keeping our inboxes free from unwanted ache. Customer churn prediction, a vital task indeed. Naïve Bayes foresees who's about to leave. Guiding businesses to take actions bold. Retaining valuable customers, worth more than gold. Fraud detection, a battle to be won. Naïve Bayes uncovers the deceivers, one by one. Identifying anomalies in financial streams. Safeguarding our resources, thwarting wicked schemes. Customer segmentation, a tale of precision. Naïve Bayes divides them into groups with vision. Understanding preferences, behaviors, and desires. Creating tailored strategies, igniting business fires. Credit scoring, a decision to be made. Naïve Bayes assesses, not letting us fade. Determining creditworthiness, risk it does weigh. Helping us make choices, paving the way. Market basket analysis, a retail delight. Naïve Bayes uncovers what's hidden from sight. Unveiling associations, products in harmony. Revitalizing sales, maximizing synergy. Oh, Naïve Bayes, a champion in its own right. With business analytics, you take flight. Classifying the world, unraveling its mysteries. Empowering businesses, creating success stories. So, let us celebrate this algorithmic treasure. Naïve Bayes, an ally we shall forever treasure. In the realm of business, where analytics prevail, it guides us forward, our compass without fail. Start planning your next global adventure with ease and convenience with our Booking.com referral link, https://www.booking.com/index.html. 8=7989335 is a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our NHub Metaverse channel, and please watch more interesting videos here.